Hey Bulldogs, today we're going to talk about inverse operations. So it's going to tie into what we did yesterday, but I want to start with a critical thinking problem. So if 493 plus 185 equals 678, what is 678 minus 185? So we want you to try and do this without a calculator. Okay, pause right now, take a second. Okay, so you should have paused the video and given this a little bit of an attempt. Now, you might have done this like the old-fashioned way, 678 on top of 185. That's how we were taught to do subtraction. And we would figure this out. We'd do 8 minus 5 is 3. We'd borrow from the hundreds place to make 7 is 17. 17 minus 8 is 9. 5 minus 1 is 4. And man, that took a long time. We could also do it easily with a calculator, and we get 493. But can you do it without one? Yeah. If you know that 493 plus 185 gives you 678, well, if we just take that 678 and subtract 185 again, we're going to get back to our original number, which was 493. Now, that's introducing what we call inverse operations. So let's review a little bit from yesterday. You should recognize these scales. These are from our homework. That scale represents an equation. The middle is your equal sign. And then you have a left side and you have a right side. So when we're looking at the left side of our scale, we have an unknown and we have these four other blocks. So let's look at our unknown. We don't know what the value is, so we're just going to represent it with the letter X. We also have 4 blocks. We have 4 blocks more than X, right? So we have X and we have 4 blocks. So we say X plus 4, and those blocks were valued at 1, so we know that the value is 4 there. On the right side, we just have 10 blocks that are valued at 1 apiece. So 1 plus 1 plus 1 plus 1, all the way until we count all 10 blocks. That gives us 10. So we can then write X plus 4 equals 10. Now we have an equation. So let's come back to this idea of inverse operations. We'll get back to our X plus 4 in a second. An inverse operation is an operation that has the opposite effect. So we've done something to a number, and then we want to undo it. Okay, so we had 493, and we added 185, and then we took away 185, and we got back to 493. So addition and subtraction are inverse operations. And it goes back and forth. Subtraction inverse is addition, has the opposite effect. Addition has the opposite effect of subtraction. The other grouping you will use in Algebra 1 is multiplication and division. Those operations have the opposite effect of each other. And another quick note is this whole idea of being equivalent. Equivalent means equal in value. So we always want to think of that scale, right? The scale on the left side and the right side, we want to remain balanced. That lets us know that it's equal. All right, so let's finish this problem using inverse operations. We said we had an unknown value. That unknown value we wrote as X. And we were adding these 4 blocks to it on the left side. They have a value of 1. Our center of the scale represents our equal sign. And on the right side, we had 10. Now, in the video on Khan Academy, they started by saying, okay, well, we want to get rid of these 4 blocks, right? We want just our unknown by itself. That's great. Now we get rid of the 4 blocks. But what happens? If we just get rid of something on one side, it's going to go up. It's going to be lighter. The other side's going to go down because it is now heavier. Now there's no equivalency. There's no balance. There's no equality between the two sides. We don't want that. So we had to take 4 blocks off of the right side. And that let us know that our unknown value is equal to 1, 2, 3, 4, 5, 6. Our unknown value was equal to 6. Now that's great. We solved it. But as algebra gets more complicated and there's more steps, this won't help us solve more complicated equations. So we need to practice solving the simple equations. So x plus 4, our operation there is addition, and you see I've circled the addition sign. The inverse is subtraction. So if we don't have blocks, we don't have a scale, if we just subtract 4 after adding 4, we're going to get back to just x, because plus 4 and minus 4 essentially cancel themselves out. Well, on the right side of the equation, 10 minus 4 is a math problem that we know how to do, and you're left with 6. So x equals 6. For the other scale, it was a little bit more complicated. On Khan Academy, they were talking about how we have 4 of something that is unknown. We have 4 x's now. We put our equal sign, because that's what the center of the scale represents. And then we count up the blocks on the right, and we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 of them. So now we have 4 unknowns is equal in value to 8. Well, on the Khan Academy video, it said, well, we're trying to get 1/4 of these, right? We would say we need 1/4 of what we have. Well, 1/4, that's like dividing by 4. So we're going to look at our initial operation, 4 times x, and that makes sense. The inverse of that is division. So we're going to divide by 4. Well, if we do it to the left side, we have to do it to the right because we have to balance our scale. We have to maintain equivalency. And 4 divided by 4, that leaves us with just 1. Okay, so 1 times anything is just itself, so x is by itself. 8 divided by 4, well, that's something we can do. 8 divided by 4 is 2. Now, here's some practice for you, okay? We're going to go through each one of these, and then we want to practice explaining it. As if you had to explain it to someone who's never learned it, we want you to be able to do that. So let's start. We're going to start with our first problem, x plus 2 equals 3. Well, my operation is plus. So what's my inverse? Well, I know addition, subtraction. Okay, so subtraction is my inverse. Since we added 2, we're going to take away 2. I can't just do it on the left. I have to do it on the right as well. And now I simplify. I'm left with x on the left, and 3 minus 2 gives me 1. And I know those things are equivalent because I've done the same thing on both sides. So now let's write out an explanation, and this will help cement this idea into your head. So what was my explanation? Because 2 was being added to x, okay, something is happening to x. Because 2 was added to x, I have to, and what's the inverse? Subtract. We must subtract 2 to get x by itself. And if you remember from the scales, the idea was to get that unknown by itself so we know how much it weighed, so we know what its value is. Okay? So there's my explanation. Now, let's do the next problem. Now we're starting with a different operation. So now we're starting with subtraction. Well, doesn't mean anything different other than that we have to identify our inverse, and our inverse is addition. So if I'm subtracting 4, I need to add 4. I can't do it to the left without doing it to the right. Minus 4 plus 4. If I have x and I subtract 4 and then I add 4 back, I'm just back at x. And then if 7 and then I add 4, I have 11. So now I've solved. I know that x equals 11. But why does x equal 11? Why did I choose to add 4? Well, because 4 was being subtracted from x. That's how we have to think about this. What is happening to our unknown? Because 4 was being subtracted from x, we must add 4 back to x to get it by itself. Only when our variable, only when our unknown is by itself, can we know its value. Okay, let's move into our other relationships, multiplication and division. So 2x equals 8. When you have the number next to the variable like that, that means multiplication. We're not going to use an x anymore to represent multiplication because we use x as a variable. So 2x is the same thing as 2 times x equals 8. Well, multiplication has an inverse operation called division. So we divide both sides by 2. We're left with 2 times x divided by 2 gives us just 1x. We just got x left over. Equals 8 divided by 2, and that's something we remember, and that's 4. So x equals 4. But why? Why did we do that? Well, again, speaking in terms of what's happening to our unknown, because x was multiplied by 2, we have to divide by 2 to get it by itself, or to isolate. In math, you'll often hear the term isolation. We want to isolate the variable. And we did that in this case by dividing, because it was originally being multiplied. All right, last practice problem. So we have x, and then we have the \2. That's how we type math problems. It's not the best way. And when you write it by hand, you'll never write it like that. So what we would write is x over 2 equals 10. That fraction bar there, that represents division. A fraction just means you're dividing the top by the bottom. So we're dividing x by 2. So the inverse operation of division is multiplication. Remember, we don't use x for multiplication. So we're going to put parentheses around our terms. And then we're going to put the 2 right up next to the x over 2. And because we did it on the left, we have to do it on the right. And that indicates multiplication, those parentheses with the number next to it. So 2 times x divided by 2, just like in our previous example, leaves us with only x. Well, now we have to multiply 10 by 2, and we get 20. So x equals 20. Our explanation here is the same as the others. Because x was being divided by 2, we have to think of our inverse. Inverse of division is multiplication. We must multiply x by 2 to get x isolated, or to get x by itself. That's how we can find the value, and the value is 20. Okay, so now, time to practice on your own. All right? Good luck, Bulldogs. Let us know if you have any questions, and we'll see you soon.